Hello everyone. In this video, we are going to discuss this particular question where a curve is given x square plus y square into y square equal 4x square and some constraints for x and y. And here we have to prove that this particular curve and under this conditions doesn't have any maximum or minimum points. Okay. And usually, so maximum or minimum we depend upon, we will differentiate, we will equate to 0. And if we solve that particular equation, we will get the points where some of the points will be maximum or minimum. In this case, it's quite different, right? It's not just a function. It's not like y equal to f of x. It's something different. Even if you try to separate y equal to f of x, it's little cumbersome process. So we will use the technique of differentiation, which is implicit differentiation. Okay. So basically, it is an implicit form. So we will differentiate it. After differentiating, our aim is to prove there is no maximum minimum. Okay. After differentiating, I will get some dy by dx forms here and there. I will replace the dy by dx with 0 and I will solve that particular equation. And we will get an absurdity. Why? Because this curve doesn't have maximum minimum. But I'm trying to say, okay, dy by dx is 0 means I'm trying to say there is some maximum minimum. So I assume a contrary and I will end up with an absurdity and hence this proves no maximum minimum. So that's the idea. Let's go to the implicit differentiation part. Before doing implicit differentiation, yeah, we can directly do that also, but remove the bracket, that will be more easy. And also there will be less chance to make mistake. So simplifying that, x square y square plus y power 4 equals 4x square. Let me differentiate. And this will come under UV method. Okay, what does the UV method says? U is x square, V is y square. What is U dash? Here, y is a function of x, right? So U dash is simple. It's a x. It's made up of x. I'm differentiating with respect to s, so it's normal. But when you differentiate V, okay, so I will differentiate to y, but I'm not differentiating with respect to y. Right? If it's differentiating with respect to y, I will stop here. So I will do some extra stuff dy by dx equal to 0. It's very simple related with the chain rule, right? And that particular y is made up of x multiplied by that differentiation. Cool. Now we can expand this. So x square y squared after differentiation, like this is how it will be, right? U dash v plus v dash u. So u dash is 2x, u dash v is y square plus v dash u. V dash is 2y, sorry, 2y dy by dx times u, which is x square. Then y power 4, it's kind of a similar stuff. That implicit differentiation plus, usually you will differentiate, right? So 4y cube multiply by dy by dx. Because I'm not differentiating x, that's why. Equal 8x. This is it's a normal because we are dealing with x. Right? And here, if it has a maximum point, if the curve has maxima or minima, local, we are talking about local maxima or minima, dy by dx will be 0. Okay, let's assume that it might have a 0, right? So substitute dy by dx in this term. Equal 0 in equation term. Okay, so what we will get? First term will not get affected. It doesn't have dy by dx. This term have dy by dx. When I place 0, everything will get vanished. Also, this third term, this also will get vanished. Let me highlight this. Okay, these will get vanished and 8x will not get affected. Okay, so no need of this plus. Equal 8x. And let's try to solve this. 2xy square minus 8x equals 0. Take a number 2 and x common, you will get y square minus 4 equals 0. Okay. So this says like x is 0 or y square equal 4. X is 0 or y equal to plus or minus 2. Okay, I got solutions, right? It's not like absurdity. It is absurdity. Let's see why. The domain is the constraints for x and y is given, right? So given x greater than 0, x equals 0 is not at all possible. So here a contradiction. And y should be between -2 to +2. The -2 and +2 are not included. So this contradicts. Why I get a contradiction? Because I assume that wrong thing, right? I assume dy by dx is 0 for this particular term. It's not possible. This contradicts that dy by dx is 0. So dy by dx not equal 0. If you can't get, like, if dy by dx is not equal to 0 anywhere, means there is no maximum, local maximum or local min. Hence, we proved it. So that's simple. We do the implicit differentiation, and here we apply chain rule and implicit rules. Then to prove this, I assume the contrary. I have to prove no, but I will substitute, okay, what if there is local maxima or minima, and I tried. I got some solutions, but when I compare with the conditions, it doesn't match. Here we got a contradiction. This means dy by dx cannot be 0. If dy by dx is not 0, there is no local maxima or minima. Okay. Yeah, thank you so much.